Welcome back, system design enthusiasts. Today we would be kicking off a brand new section in our series called as the buzzwords. You know the fancy terms that tech folks just love to throw around? Let's uncover them one by one and see what they really mean. We start with the design goals. Design goals are key ideas that help us build great systems. They make sure that our systems work well, it's easy to use, and can handle a lot of users. We'll get started with one of the most important design goals, scalability. I'll begin with a simple example. Imagine a small, cozy bakery in your neighborhood. When the bakery first opened, they just had one cashier and everything ran smoothly. Customers would come in, place their orders, pay at the counter, and then leave satisfied with their delicious pastries. But then, slowly, the bakery started gaining more popularity. The line of customers grew longer and the waiting time increased. People began to feel very frustrated, and some even walked out just because they didn't have the time to wait. So, to tackle this problem, the owner of the bakery decided to open additional checkout counters. Now, instead of one cashier, there were three. This made it much easier to handle the growing crowd, reducing the wait times and keeping the customers happy. So, effectively, the bakery had scaled up to meet the increasing demand. Just like our bakery, our technical systems also need to scale up as more and more users join. Scalability in tech is effectively the system's ability to handle more work smoothly as the demand grows. A well designed system can scale up more easily, ensuring that it can serve more users without any performance issues. Let's talk about another critical design goal, availability. Availability means how much time a system is up and running. Think of it like your favorite 24/7 convenience store that's always open, day or night, whenever you need something. Another example, online banking. When you access the online banking website that's available 24/7, it greatly improves your experience. It ensures you can access your account, perform transactions any time of the day. You wouldn't want your bank to be on a break when you need to transfer money urgently. We often express availability in nines. What is nines? I'll give you an example. When we say a system has 99.999% availability, also known as 5 nines, it means the system is allowed only 5 minutes of downtime per year. 5 minutes or 0.001%. That's incredibly available. It's like your favorite convenience store just being closed for 5 minutes in 1 year. We'll begin with the next important design goal, that is consistency. Consistency means making sure everyone sees the same information at the same time. I'll start with a simple analogy. Imagine a teacher announces that there is a test tomorrow. If the teacher tells all the students at the same time, that's consistency. But if only half of the students hear the announcement and the other half don't know about the test, that's inconsistency. There are two types of consistency: strong consistency and eventual consistency. What is a strong consistency? Strong consistency means that as soon as the information is updated, everyone sees the same updated information immediately. There is emphasis on the word immediately. That is, there is no delay. Eventual consistency. Eventual consistency means that the information will become the same for everyone over time, but not right away. There might be a short delay before everyone sees the updated information. I'll start with an example to explain both of these concepts. Suppose that you have $1,000 in your bank account. You withdraw $200. The bank updates your balance to $800 immediately. Now, if you or someone else checks your balance, it shows $800 right away. On the other hand, consider the example for eventual consistency. You have $1,000 in your bank account. You withdraw $200. The bank might still show $1,000 for a short time. And it is only after some delay, like 1 hour, the bank updates the balance to $800. Now, in some situations, strong consistency is crucial, while in others, eventual consistency or delayed consistency is acceptable. The example that we were looking, the bank transactions, strong consistency is of utmost importance. If the balances don't update immediately, it could lead to errors, like withdrawing the same money twice. On the other hand, consider the example of social media posts. Eventual consistency is fine. If you post something on Instagram, it's okay if there's a small delay before all of your friends see it. As long as everyone eventually sees the post, there's no major harm. A fun fact, did you know that early banking systems had big problems with consistency? Sometimes people could withdraw the same amount of money more than once just because the balances didn't update quickly. This actually caused huge financial losses. This is why strong consistency is so important in the banking today. Today, we are going to talk about another important design goal, and that is to ensure that our system does not have a single point of failure. I'll start with a simple analogy. Imagine that you are crossing a bridge. That bridge is supported just by one pillar. Now, if that pillar collapses, the entire bridge falls. That pillar is the single point of failure for the bridge. If it goes down, the whole bridge is unusable. Similar to this, we don't want any single point of failure in our system. Let's use our website example. A user tries to open the website. Client requests the web page. There's a server that handles the user request and it fetches the web page from the data store. Now, what happens if this server goes down? The entire website becomes inaccessible. Here, the server is the single point of failure. If it fails, none of this flow is going to work and everything stops. Now, how can we avoid single point of failure? Naturally, by adding more servers, also known as by adding redundancy. This makes our system more tolerant to failures. So if one part fails, others can take over, ensuring continuous operation. Technically, we say that we have made our system fault tolerant. Some examples of a fault tolerant system. If one server in the data center fails, another server comes to take over, and the website remains accessible to users. Perhaps if the entire data center fails, another data center takes over. The website remains accessible again because the secondary data center steps in to handle the traffic.